Hello guys, welcome to another wonderful episode of CUDA Education. I'm your host, Nicholas Main. So today what I wanted to talk about was how to get started programming in CUDA. So basically you have an NVIDIA graphics card on your machine and you would like to learn how to program it and take advantage of all the processing power that your GPU has. For most things, especially when you're dealing with graphics or straight arithmetic and stuff like that, you could take advantage of your GPU, take advantage of what they call parallel programming, and achieve your whatever you need to get done in your application a whole lot faster on a GPU than a CPU. So there is a big process on how to go about doing this, and the best way to go about doing it is, of course, learning through CUDAeducation.com. So this is intended to be a quick video, so I'm just doing a quick overview. The first thing you want to do is visit CUDAeducation.com/how to program CUDA, this address right here. And what I have here is written out very plain instructions on how to go about programming your NVIDIA graphics card. Now, I do have a walkthrough video, a very extensive walkthrough video on how to go through the steps, but I also outline it here. So, I'll just go through the written instructions very briefly. You need a CUDA-enabled NVIDIA graphics card, and you need to check this link here to make sure that you have a CUDA enabled graphics card, and then you also want to make sure that on the graphics card on this list that you have a compute capability of, I think it's like 3.0 or higher. So the latest CUDA toolkits, they deal with compute capability 3.0 or higher. The compute capability is related to the architecture of your GPU, so different cards have different architectures, and it's all related to the compute capability. So you want to make sure you have 6.1. Well, you want to make sure you have above 3. Now, this tutorial is basically dealing with a Windows-based system. So I have a Windows 10 operating system. I have a NVIDIA GeForce 1050 Ti graphics card that runs compute capability 6.1. And I integrate it. So part of the installing the toolkit is to integrate it with Visual Studio, which is sort of the GUI that NVIDIA uses to interface with the the code and the programming on the GPU. So all sort of detailed instructions here, right? Check your compute capability. And then you download Visual Studio Community 2017. Now I have the Community Edition is free, so you don't have to worry about paying. So you could download Visual Studio Community Edition 2017. It's a big download. It takes a lot of time. You want to install Visual Studio Community. Make sure that you install it first, so that when you're installing CUDA Toolkit, that it recognizes that you have a Visual Studio installation and it can sort of integrate the two. But again, if you go to this website here, CUDAeducation.com/how to program CUDA, it will give you detailed instructions on how to do it. You also have to choose workloads and modules and different attachments during the installation of Visual Studio. Modify tool sets, all that good stuff, individual components. And then you're going to download and install CUDA Toolkit. Currently I'm on CUDA Toolkit 10, and CUDA Toolkit 10 is available, but I highly recommend, just because this tutorial is going through CUDA Toolkit 9, and CUDA Toolkit 9 for anything that you would need right now is perfectly relevant for what you would need. I recommend just doing CUDA Toolkit 9 and following the video and the instructions here, just to eliminate all kinds of anomalies or any things that might happen outside of this video. So download CUDA Toolkit 9 and you could follow the video. Make sure you download the relevant patches also. but you do the base installation first and then you put on the patches. On CUDA Toolkit 10, there currently isn't any patches. This video is created the January 2019, so maybe there'll be patches for CUDA Toolkit 10 later on. But again, just focus on CUDA Toolkit 9, and you could go to the download archive website and get the CUDA Toolkit 9. And then basically what you want to get to is you could open a new project in Visual Studio and just choose a CUDA project, right? So the project will be a CUDA project. And then for CUDA Toolkit 9 specifically, you do need to change the compiler that is used. So you do Visual Studio 2015 version 140. The default compiler in Visual Studio 2017 doesn't work with the CUDA Toolkit 9 project. I think on CUDA Toolkit 10 it works fine, but if you're going to do the CUDA Toolkit 9 version, download and everything, you have to switch to Visual Studio 2017 for the platform tool set or what have you. And then you rebuild and rebuild or build the code and run it, and you should get, the default project when you open up a CUDA project is a simple addition of 2 arrays, right? And congratulations, you have successfully run CUDA, and you can start coding and stuff. Now, of course, this is CUDA Education. I have a bunch of tutorials, so this is a website you could go to, CUDAeducation.com/CUDA code to get a walkthrough of the default code that appears and for you to understand how the CUDA code works and all that stuff. And then also, just so you know, if you go to CUDAeducation.com, you could go to the you could go to just the CUDA NVIDIA CUDA category here. Actually, should be here too. Or maybe not. Right. You can go to the NVIDIA CUDA category, and you will get all videos, all tutorials related to running CUDA. So I wouldn't recommend you doing the OpenCV and CUDA module because that's a whole nother thing. But you could do CUDA dynamic parallelism. That's how to launch another kernel from the GPU itself. There's a whole bunch of stuff. There's a CUDA fluid dynamics example, a simulation. You can learn about CUDA pin memory and how to use pin memory to speed up your application. There is a ray tracing example. I talk about my experience of upgrading to CUDA Toolkit 9. So I started from scratch with CUDA Toolkit 9, and then I upgraded to CUDA Toolkit 10. So my experience might be a little different than if you're straight just trying to install CUDA Toolkit 10 from scratch. And then I discuss some errors here, and there's a bunch of stuff. So environment variables, CUDA streams, and for most of my examples I have code that you could just copy and paste and sort of run on your system. So it's really easy, and then I usually have a video associated with them to explain what the code is and what I'm doing. CUDA cooperative groups, this is a fairly new feature. And then I do a CUDA Toolkit 9 code walkthrough, so I'm talking about a specific coding example, talking about thread mapping, threads, blocks, grids, and explained in CUDA. Most of these posts again have videos, so you could just click into them and you'll get videos and stuff. So that's a quick overview of how to start programming CUDA Toolkit 9, and if you want to, CUDA Toolkit 10. So remember to donate whenever you get the chance. Donate is right here. Just press this button and you could donate as much as you want. And yeah, I hope you guys for the new year start to program your GPU and understand and learn how to use your NVIDIA GPU to process data and to do a lot of interesting things, whether it be graphics processing, image processing, computer vision, simulations, mathematical modeling, all that good stuff, artificial intelligence, deep learning, all this stuff. You could take advantage of your GPU to do it. So it will take a little time, but it's definitely not impossible, and it's definitely not extremely difficult. It's just that you have to follow the steps, play the video, and read the instructions, and you should be good to go. And of course, always visit CUDAeducation.com. You can catch me on Twitter at CUDAeducation. Donate to the cause. You could join the mailing list also for anything new I have to say or anything interesting I have to say. I'll push out a mail. I don't usually send out mails often, so I'm not going to be spamming your inbox too much. And yeah, just work through. I also, on CUDA Education, you also have TensorFlow related stuff. So TensorFlow more deals with the artificial intelligence side of things, and TensorFlow, there's a TensorFlow GPU version that basically takes advantage of your GPU to process the neural network and all that good stuff. So you could definitely do that. What else? Oh, there's also teaching and consulting. So CUDA Education, there is a way where if you want to teach a classroom, or if you want me to teach your company on how to take advantage of your GPU in order to process information faster, to speed up your application, or you just want to teach your staff on how to benefit from your NVIDIA graphics card, definitely reach out. You can reach out at CUDAeducation@gmail.com, and we could set up something. There's teaching sessions available, consulting sessions available, all that good stuff. It's definitely more efficient than necessarily everyone trying to figure it out on their own. CUDA Education definitely can help you to do that good stuff if it is that your application will benefit from GPU processing. Anyway, guys, I wish you all the best for the new year. I hope that you achieve all the things you want for 2019. Remember that time is the master, so make good use of 2019 and all it has to offer. Have a great day.